Hey, boys and girls, it's Miss Holub. I hope you're having a wonderful day wherever you're at. And today for science, we are going to be talking about bridges and how you can make a bridge with almost anything. So what is a bridge? We've heard that word before. Think about any kind of story you read that had a bridge. There you go. Okay, so today we will observe and describe the position of things, and we will decide, we'll do a little experiment, a little trial, how many pennies or coins can you hold with one tissue, and then if you add another one. So we're going to think about how sturdy our bridge is. So let's go ahead and take a look at some examples of bridges.
Oh, hi guys! Squeaks and I were just playing with some blocks. You know, it may not seem like it, but the cities and towns that we live in are all built using the same rules as our little pretend village over here. It's just that the real ones are bigger. And one of our viewers, 6-year-old Hannah from the UK, wanted to know how some of the things that we build stay standing. So she sent us a really great question. Why are bridges so strong? Excellent question. Sometimes when a road or railroad track needs to go across something big like a river or a deep valley, experts called engineers design and build bridges to do that job. And bridges can be really busy. Take, for example, what's said to be the world's busiest bridge, the George Washington Bridge in New York City. Look at all those cars and trucks. It has to be pretty sturdy to carry so many people and cars. For a bridge to carry that much weight, it has to be built of special material like iron and steel. But it takes more than tough materials to make a strong bridge. So let's look at how bridges work. One very simple kind of bridge is called a beam bridge. When we say simple, we really do mean simple. A beam bridge can be just a log that you use to walk across a stream, or put a long strip of cardboard between two short blocks. That's a beam bridge too. All bridges can hold a certain amount of weight, but what happens if we put too much weight on a beam bridge? Let's find out. It collapses. So a bridge that carries trucks and cars, which are very heavy, would have to be stronger than a bridge that carries bikes or people on foot, which are lighter. So how do we make stronger bridges? Well, over time, people have learned that certain shapes can be used to make stronger bridges. Take a look at this railroad bridge. It has to be strong because it carries trains. What shape do you see? That's right, triangles. And that's not by accident. The fact is, triangles are really strong shapes for building. If you put force on one side of a triangle, it bends. But if you put force on its point, it keeps its shape. That's because the two sides of the triangle are pushed down by the force, and the bottom gets stretched out to both sides. Each side feels the force, but none of them bends, and this makes the triangle a really sturdy and stable shape. This is why you'll see lots of triangles and bridges, both above the part that you actually travel on, called the deck, and below it. The long string of...
Alrighty. So that gave us some background for today's activity. Let me get, so you can see me. Here I am. Okay, so let's go back to what we're doing. We will decide how many pennies or coins you can hold with one tissue and then with two. So I have a little example here. Okay, so let me show you what mine looks like. So I decided I wanted my bridge to have 1, 2, 3, 4 towers. Okay, and mine are about, I knocked one down. 1, 2, 3, 4, 5 little linking cubes long. Now you can use pattern shapes. You can use whatever you have materials around the house. But the thing we need to make sure we have is at least a couple of tissues and a coin. If you don't have a penny, just any kind of coin. So here's my coin. Here's my tissue, right? Now I'm going to put it on top. Do you see how close they are together or how far apart? I'm going to put my tissue on top. And let's see if I can hold one penny. I can hold one penny. Let's see if I can hold another penny. Oh, Miss Holub could not hold another penny. If I added another tissue, would I be able to? You are going to tell me. Excuse me. Hold on. Okay. So, after you complete the experiment, you're going to fill out the Google slide right here. So it's going to say number of tissues used. So if I was doing this, I could write 1. I used 1 tissue. How many pennies could I hold? I could only hold 1 because what happened when I held 2? It fell, right? So then my next trial, I would then put another tissue, and then I would see how many pennies or coins I could hold. And when you're done, make sure you click submit and turn in so your teacher can see your work. And then I want you to think about some questions to think about. Think about what happens if you move the towers or the linking cubes that you used. If you move them closer together or farther apart, what would happen to the tissue when you put it on? Would it make it stronger? Would it make it fall apart? What would it do? Okay, and just to review, why is this important? What about if you're building a tower with your friends and you want to know which one's the strongest? You want to say, oh, I can make mine the strongest. You need to know how to build it. You need to know how many cubes. You need to know how much space do you put in between, right? Well, that's it for today. And have a wonderful beginning of the week for science. Since today is Wednesday, we will see you tomorrow, Thursday, right back here, same time, and we might have a special guest. All righty. Bye, guys.